Hello everyone. For my senior project, I decided to do the RC Baja car, and I did the suspension and chassis portion of the project. For this project, I wanted to demonstrate the ability to design, manufacture, and perform in the ASME Baja competition. Here are some early drawings of what I wanted the chassis and suspension to look like. The requirements of the car were the cost of the parts for the Baja car should be limited to $600. The Baja car must be able to withstand being dropped from 1.5 feet. The chassis must weigh no more than 8 pounds. The outside dimensions, not including the wheels, must be no larger than 1/10 scale, and it must be remotely operated. The suspension must handle at least 50 newtons of force, and the car must be able to survive a collision with the wall going at least 7 miles per hour. During the design process, I had to complete 12 green sheet analysis. The first analysis was determining the thickness the chassis needed to be to withstand a 1.5 foot drop or 100 newtons of force. The second analysis was the impact force of the 1.5 foot drop. The third analysis was taking the energy absorption from the 1.5 foot drop and finding the minimum screw diameter. Analysis 4 was finding the minimum allowable screw diameter to withstand the impact and not fail at the screws. Analysis 5 was the buckling analysis on the suspension support. Analysis 6 was the maximum angular velocity of the wheels. Analysis 7 was conducted to find the critical load of the chassis before buckling. Analysis 8 was finding the geometry necessary to attach the shocks to the suspension tower and the A-arm. Analysis 9 was finding what the K-factor of the springs needed to be. Analysis 10 was the minimum allowable diameter for the hinge pins. Analysis 11 was the analysis of the RC car sustaining a front impact into the wall or an object at 20 miles per hour. Analysis 12 was the bending stress on an A-arm. Due to COVID-19, the first 2 weeks of winter quarter, nobody was allowed on campus. So this made the time frame to manufacture the car very tight. So due to this, I decided to focus on 3 parts to manufacture. First was the suspension, second was the suspension tower, and third was the A-arms. For the chassis plate, I started by getting the donated material and cutting it to the desired shape. Once I had the desired shape, I started to cut the slots where the A-arms was going to attach to the chassis plate. Originally, I was going to mill the slots for the A-arm to attach to, but once the chassis plate was made into the shape I needed it to be, it was found that it was going to be too big to fit into the vise for the end mill, and there was going to be too much deflection if I put it in the other way. So the only option I had was to cut away what I could on the bandsaw and then file away the rest. The next part manufactured was the suspension tower. First, I cut the donated material into the desired shape, and then I began drilling holes and tapping them. Here, this is the top of the suspension tower, and I'm drilling the holes for the shocks to attach to. Next, I began cutting the leaf springs that were donated, and we needed a couple leaf springs, and they needed to be shorter than the donated material. Here's a video of me drilling the holes into the chassis. Here's the SolidWorks drawing of the chassis. Here's the top of the suspension support, since at the time I did not know how we were going to manufacture it to attach to the chassis. How we ended up manufacturing it was making a base that would attach from here to here with pins being put in between them to hold on to. And here's the assembly drawing of the car. I believe that this came out very well and represents the car very well, since it's very similar to the car how it came out. I needed to conduct 4 tests. The first was a drop test, the second was a front impact test, the third was a suspension loading test, and the fourth was weighing the chassis. Here's the car before the first drop test is conducted. And here's the first drop test. As you can see, the car failed on both right A-arms. Here's some pictures depicting that. So after the car failed the first drop test, I decided that it was because of 1, the material wasn't strong enough. So to fix that issue, I decided to make them out of a stronger material. And 2, they needed to be printed on a higher quality 3D printer. So for the second drop test, before completing it, I reprinted them on a higher quality 3D printer and out of a stronger material. Once that was done, it was able to survive the 1.5 foot drop the second time around. The second test, the car drove into the wall head on with about half throttle, which was approximately 7.5 miles per hour. The car was able to survive it easily. Nothing broke on it. The third test was the suspension loading test, where we evenly distributed 15 pounds on the front and rear suspension and to see if the car would bottom out, which it didn't. It survived. It was able to hold the 15 pounds. The last test was weighing the chassis. The chassis only weighed 3.5 pounds, which is well below the 8-pound maximum requirement. Here's the schedule for fall quarter. For fall quarter, I made the proposal and did the 12 analysis. Winter quarter was manufacturing and designing the website. Spring was testing and continuing on with the website. I didn't spend any money for my part of the project. Everything I used was either donated or used from a previous year or previous project. But this is the budget from my partner Jason. It totaled out to where we only spent $418.84, which is well below the $600 maximum. If you have any questions or would like to see the actual analysis that was conducted, the green sheets, you can view them through the report that's linked to my homepage, or you can email or call me. Thank you.